Okay, I don't subtract or add anything to get started. I'll be doing something going like that going on later. But what do I have to do first? I need to convert it, and in order to convert it, I need to draw it. I need to draw it. So I'm going to draw over 2 root 2 and down 2 root 2. Now, why am I drawing it? What am I trying to figure out? The radius. Okay, square this. What do you get? 4 times 2, so you get 8. That's 8 when you square it. What's that when you square it? 8. 8 and 8 is 16, and the square root of 16 is 4. So your radius is 4. What else are you supposed to be figuring out? Theta. Now, you're going to have a calculator, but see how these two match? When those two match, what is that angle always? 45. But be careful. Oh, did that fall down?
Yeah.
Okay, can't jostle over here. Keep in mind that that angle is in quadrant 4. So what does that mean if the angle is in quadrant 4? I'm going to have to subtract it from 360. Right? Alright, so I'm going to subtract it from 360. And what is my actual angle going to be then? 315. So I have a 4 CIS 315. My radius is 4. My angle is 315. Now I need to raise that to the 5th power. So how does that work? Now we take 4 times 4 times 4, 5 times. So what do you get when you take 4 times itself 5 times? 1024? Now why am I doing this? Because I remember that when I multiply numbers in polar form, what do I do to these? Multiply them. Well, there's 5 of them, so I multiply 4 times 4 times 4, right? 5 times. Now, what do I do with these? I add them. So I've got 315 added up 5 times. So I get 1575. So we multiply this times itself 5 times. We add this 5 times. Now that would be the answer, except what? That is too big of an angle, right? So we're going to subtract as many 360s as we need to. And you have a calculator, so you can do that. And I came down to 135. So that is the final answer to the problem. Okay, that's a question on the test. It's on the pre-quest. It's just extra practice. Zach?
So you just subtract a bunch of 360s, but you
Yep.
Until you get to a small number.
Yep, until you get to less than 360. All right, question number 2 says -2 minus 7i, and we're going to convert to polar form. Now, you have already done this because we started, oops, I forgot the I in there. We started with that number, and what was the first thing you did to it? You converted it to polar form. Okay? So what am I going to do with this right here? What am I going to do with that? How am I going to change that to polar form? I'm going to draw it. And how am I gonna get, or what am I gonna find from that picture? What is that picture gonna tell me?
Radius.
The radius, which will be the square root of 53, very good, Jamal, the square root of 53. And the angle, now this one I could get by without a calculator because they matched. This one I'm gonna need a calculator. And what am I gonna type in on my calculator to find the angle right here? What am I gonna type in on my calculator? Second tangent, what? 7/2. Opposite over adjacent, y over x, 7/2. So second tangent, 7/2 is 74.05. Now, if I said it once, I've said it a million times. The only time you use the angle on the calculator is when what? You're in the first quadrant. Am I in the first quadrant? No. So I'm not going to use 74.05. I'm going to have to make an adjustment.
Add it to 180.
So this one will be 180 plus 74.05, which would be 254.05 if I added right. And that is the answer to the question. That is your polar form. Polar form means CIS. Okay?
Wait, how'd you find the 254?
180 plus 74. R equals 4 secant theta. Now we are going to write this as a rectangular equation. All right, we did a couple of these yesterday. Step 1, who remembers how we start this?
It's a secant, so isn't it different from the rest?
Well,
You said it's different.
well, obviously it's a secant, so we start with what? R over R over X. It's the reciprocal of the cosine, so it's going to be R over X. So what's step 1? Always in these kinds of problems, change the function into its definition. Okay? Now what's step 2 always? Get rid of the fraction. So in this case, I'm going to multiply both sides by x. So I'm going to have Rx equals 4R. Now wait a minute, what do you notice about that? There's an R on both sides, isn't there? What am I going to do? I'm going to divide by R. And what am I going to be left with when I do that? X equals 4. Now, why is it wrong to stop here? Well, what do the directions say? Rectangular. And what are your rectangular variables? X and Y. If you still have an R, you're not done. You have to have only X's and Y's in your final answer because it said it has to be rectangular. What does number 4 say? The answer is X equals 4. Convert to rectangular coordinates 10, 200. Okay. All right, here we go. You want rectangular coordinates. Savannah?
So for number 3, what's the y? Because you just said that you have to have x and y.
No, you can only have X's and Y's. You don't have to have a Y, but those are the only letters you're allowed to have. This is a rectangular equation because the only variables in it are either X's or Y's.
So it's not wrong to stop there.
This is the answer.
Okay.
It's wrong to stop here, but this is the answer to the question. That's it. All right, how do I convert to rectangular coordinates?
Your radius, r, cosine.
Exactly. I am looking for X and Y. And how do I find x and y? X equals 10 cosine 200, y equals 10 sine 200. If you want x and y, that's how you do it. So 10 cosine 200 negative 9.4 basically, and 10 sine 200 negative 3.42. Now notice how I wrote my answer. Was that the right way to write my answer?
Yeah.
Yes, because the question said coordinates, and what does coordinates always mean? Ordered pair. Ordered pair. Sometimes it's r comma theta, but it's always an ordered pair when you write coordinates. All right, one more, and then you can get started on your pre-quest. What's that last one? Sketch 4 sine 3 theta. All right, before I sketch it, tell me what shape it is. What am I expecting on my calculator? I'm expecting a rose. Tell me about this rose. No. They're going to be 4 long, so when I draw it on my graph paper, which I will have to draw it on the graph paper, the petals will come out to the 4th circle. Right? Now, how many of them will there be? No, just 3. Now, again, you're going to have a calculator for the whole test. So when you graph this, it's going to show you 3 leaves, right? It's going to show you that. And then you have to take what's on the calculator and transfer it over to here. All right, so let's see if we can do that. Now, tomorrow, I will not be doing any calculator adjustments for you. 0. You are on your own. I am telling you that unless it's a spiral, which it's not going to be, so you can forget that. I told you I'd help you with the spirals. It's not a spiral, it's one of the other ones. So you're on your own. How should theta min and theta max and theta step be set up? If you're in degrees, and I would recommend you be in degrees, then theta min should be what? 0. Theta max should be what? 360. Theta step should be what? 5. That should never change. Now, x min, y min, x max, y max, those can change. What are those going to depend on? How big the shape is. So in this case, you've already told me the leaves are going out 4 units. So whatever you set up here, it's got to be bigger than 4. I wouldn't set it up like at 100, because then your picture is going to be all squished up in the middle. Make it like 5 or something. If this had been a 40, then you're going to have to make your x mins and y mins big enough to accommodate 40, right? Now, let's suppose it is 40. And you have to transfer it onto this graph. You're saying, whoa, wait a minute, Mrs. Ford. I only have 5 circles. Well, what do you do in econ when you have great big huge numbers that you have to put on a piece of graph paper? What do? You change the scale. So if you happen to have a big number like 40, you can make these circles worth 10. So 10, 20, 30, 40. And all you have to do is mark that on your paper, just like you do in econ. So you can change the scale just like you could do on regular graph paper. But we don't need to do that because it's a 4. So here we go. I'm going to put it in my calculator, see what it looks like.
How
Yes,
do you
Erica?
get theta min, like, that part of it?
What?
How do you get, like, the theta min and theta max?
Go to your window. Are you in polar mode?
No.
Well, that's your problem. You got to be in polar mode. we're graphing a polar equation. All right, so did you get a picture that looks like this? Did you get something that looks roughly like that?
Mrs. Ford, how do you get this now?
You really shouldn't be doing any zooming. You should be adjusting your window. Now, again, I am not going to be all hung up about shape. You can your X min and X max should match. I mean, -5 and 5, or -6 and 6. And your Y is the same. So did you get something that looks like that? I'm going to be really picky about going out to that fourth circle. If they're 4 units long. Okay?
Which one is it that we have to do the 2 for? If you're positive and negative.
Which equation do we have to graph 2 versions of? Anybody remember? The lemniscate. And why do we have to graph 2 equations for a lemniscate? Because the equation is r squared, and I can't put that into my calculator, so I have to take the square root, and I put in r equals the positive square root, and r equals the negative square root.
Okay.
All right, now I want you to get out request number 2, which I have also given you the